In December 2015, SpaceX landed an orbital Falcon 9 rocket booster back on the Earth for the first time in the history of human spaceflight. And in the 8 years since, SpaceX remains the only rocket provider who can accomplish this feat. In fact, no one else has even tried. So, what's the deal with that? How did SpaceX come out of nowhere and leapfrog over companies that had already been launching rockets for decades? Could it be that Elon Musk is an unprecedented super mega techno genius? Yeah, maybe, but we think that there's a much more fascinating and satisfying answer to be found here. So, let's get into it. This is the space race. If there is one defining factor that sets SpaceX apart from the rest of the aerospace industry, it is the reusable rocket. SpaceX has completely reinvented this technology in a way that no one has ever dared to dream. But that's not entirely true, is it? Obviously, someone down the line must have had the thought that maybe it would be better to try and keep these gigantic rocket boosters instead of just sending them to the bottom of the ocean every time. And we all know that the space shuttle was already reusable, right? Even Blue Origin can land their rocket booster the same as a Falcon 9. If you ask other leaders in the aerospace industry, they'll try to tell you that reusable rockets are not actually any more economical or sustainable than the traditional method, and that landing a booster is more of a parlor trick than an innovation. So, what is it that really sets SpaceX apart then? To find the answer, we have to go back to the beginning. The first rocket boosters to ever send a payload into outer space were simply reconfigured intercontinental ballistic missiles. The Titan II, which served as the launch booster for NASA's Project Gemini, was originally designed to send a 9-megaton nuclear warhead halfway around the world. So there's only so much we can realistically expect them to do. When it came time for the Apollo missions to the moon, NASA was ready to design their first bespoke orbital rocket, the Saturn V. It was a humongous vehicle that to this day still dwarfs nearly every rocket ever produced, and yet only the relatively tiny crew capsule at the very top ever returned to the Earth. The rest was either dumped in the ocean, left floating in space, or abandoned on the surface of the moon. This seems like a waste of money and resources, but in reality, it was the preferred option for NASA to make the Saturn V entirely disposable. This was the most economic choice at the time because the Saturn V was only ever intended to fly around a dozen missions, and it was calculated that the cost to build 12 disposable rockets would still be cheaper than developing just one reusable rocket. Besides, the engineers at NASA were already looking towards the future. Even before the first person set foot on the moon, NASA was developing their space shuttle concept, a fully reusable rocket plane and booster system that would be the true answer to sustainable human spaceflight. NASA's chief architect of the Saturn V, Wernher von Braun, perfected his concept for the Fairy rocket back in the mid-1950s. The former Nazi rocket scientist would come to be known in America as the father of space travel. We didn't really find out about the Nazi thing until after he was dead, so we can only appreciate how screwed up this was in hindsight. Anyway, the Fairy rocket was going to be the vehicle that brought human spaceflight to the mainstream. The 3-stage rocket would be fully reusable, with the 2 first booster cores coming down softly on parachutes and the 3rd stage orbiter gliding back to Earth for a runway landing. We should probably do a full video someday just on the Fairy rocket concept alone. What do you think? Let us know in the comments below. Anyway, you'll notice that this all sounds pretty similar to what the space shuttle ended up being, yet still quite different in the fundamental design. While the space shuttle has generally been billed as a reusable spaceplane, the more correct terminology is generally considered to be refurbishable. But what's the difference? If you go to an airport, you can watch a plane land, unload its passengers and cargo, then get rapidly cleaned, restocked, and refueled before taking on a load of passengers and lifting off into the sky yet again. That all happens within the span of about an hour or maybe even less, so we can safely say that a commercial airplane is reusable. Now, if that same airplane had to be fully disassembled, inspected, serviced, and put back together after every single flight, does that still fit the same definition of reusable? Not so much, and it certainly doesn't sound like a sustainable way to operate a commercial airline. That is the issue that NASA faced with their space shuttle. It could technically be reused which fit the initial criteria that the agency was granted by US Congress when the shuttle was funded back in 1972. But the procedure involved to actually get a space shuttle and its twin booster engines back on the launch pad after being flown just one time ended up totaling around 650,000 hours of combined labor spent on transporting and refurbishing the system. Obviously, that all happened simultaneously, not sequentially, otherwise it would take 74 years to refurbish one space shuttle. The thing about reusable rockets is that they are only valuable if the frequency of launches is great enough to outweigh the cost of developing and utilizing the technology. So, like we were saying before, this is how NASA decided it was cheaper to launch 12 disposable rockets instead of developing one reusable system. And at what point does a reusable rocket actually start to make sense economically? How many launches does that take? NASA never really had the chance to find out. Not only did the space shuttle need more work to refurbish than had been expected, it never flew anywhere near as frequently as NASA envisioned either. In the end, it would have been cheaper or at least just as expensive for NASA to throw every space shuttle in the garbage after one flight and build a whole new one. So, if you want a good answer as to why none of the commercial rocket companies ever tried to develop their own reusable vehicle, it's because they already saw what happened with the space shuttle. Not only the most expensive rocket ever developed, but also the most dangerous and probably the least successful at fulfilling its original design concept. And if NASA couldn't do it, then obviously no one else would even stand a chance, right? I want to talk about something super important, our internet privacy. Whenever you're online, your device transmits a ton of information out into the open. Hackers on the same Wi-Fi network can steal your personal data with ease, including sensitive information like passwords, keystrokes, and even your photos. But don't worry, our superhero sponsor, Private Internet Access, is here to save the day. It protects your personal data by encrypting your internet connection, making your information shielded and bulletproof. Plus, it comes with loads of entertainment benefits. PIA VPN works with all major streaming services and has 84 countries to choose from and all 50 US states, so you can access more content anywhere in the world. And the best part? Private Internet Access is available for all platforms, and with one subscription, you can protect an unlimited amount of devices at the same time, so the whole family can be protected. And guess what? I've got a special exclusive offer for you. You'll get a discount on your subscription and a 30-day money-back guarantee, so it's risk-free. And if you ever need help, their 24/7 customer support is available. And don't just take my word for it. Private Internet Access is rated excellent based on over 8,500 reviews. So if you care about your internet privacy and want to access more content, check out Private Internet Access. I've put a link in the description box below so you can stay safe and stay protected. Then along came SpaceX, who decided that they will succeed where all others have failed. Now, to be fair, SpaceX did come at the problem from a much different angle than NASA had taken with the shuttle, and in many ways, their approach with the Falcon 9 does make a lot more sense from a logistics standpoint. Something that SpaceX had envisioned from the very start of their development with the Falcon 1 rocket was recovering and reusing both the first stage booster and the upper stage vehicle by having them execute a propulsive return to launch site and landing maneuver. Now, they gave up on recovering the second stage pretty early on, and that's a reasonable concession to make because with a conventional rocket, the upper stage is a relatively simple vehicle that consists of just one engine, a couple of small fuel tanks, and a platform that holds the payload until it's time to deploy. But recovering the first stage booster is a much more valuable proposition, as long as you can make that booster fully reusable, not just refurbishable, and then fly it often enough to make the extra effort worthwhile. Of course, SpaceX opted for the most technically challenging recovery method there is, the propulsive landing. This was unprecedented territory. Back in Wernher von Braun's old ferry rocket concept, the booster stages would fire their engines on the return to Earth as a way to help slow them down, but ultimately they would land in the ocean water under giant parachutes, and NASA had successfully recovered the space shuttle's twin booster engines by simply parachuting them back down following stage separation. So why didn't SpaceX use parachutes on their Falcon booster? Short answer, they tried, but physics wouldn't allow it. Parachuting the shuttle boosters worked for two reasons. One, they were pretty small and pretty light, being solid rocket boosters, Once all of the propellant is burnt up, they're basically just empty metal tubes. 2, the shuttle boosters separated at a relatively low altitude and therefore a relatively low velocity of just around 4,800 kilometers per hour. They were only really necessary to get the shuttle off the ground and through the thickest part of the atmosphere. After that, the shuttle still had 3 incredibly powerful hydrogen-burning RS-25 engines that continue pushing to reach orbital velocity. In a single-core, 2-stage rocket like the Falcon 9, that one booster has to impart a tremendous amount of velocity into the upper stage so that the final vacuum engine can continue to accelerate the payload into orbit. This means the Falcon booster will fly much higher and faster, reaching a speed over 8,000 kilometers per hour at stage separation. The formula for kinetic energy is 1/2 mass times velocity squared, which, in the case of a Falcon 9 booster that just released an orbital payload, equals way too much energy for any parachute to withstand. That is why von Braun envisioned the hybrid of engine deacceleration combined with parachute-assisted landing. But this is Elon Musk philosophy we're talking about now, and the best part is no part. The rocket already has engines, so why bother adding parachutes to lower velocity when the engines can do the exact same thing? The engines on the Falcon 9 also serve a dual purpose as a free heat shield to protect the booster as it re-enters the atmosphere. So, in the case of a drone ship landing scenario, the Falcon 9 booster is going to coast up and clear through the atmosphere, crossing over the Kármán line, and technically being in space for about a minute or so. But since it's not traveling at orbital velocity, the booster is eventually going to fall back down. As this begins to happen, the booster is going to flip around and point its engines in the opposite direction to perform a re-entry burn. The maneuver is going to start killing a ton of the booster's velocity, which is important, but even more critical, the thrust from the engines will create a force field underneath the rocket that protects the metal from the extreme heat of re-entry. That's when you see the crazy jellyfish-looking cloud of smoke and fire build up underneath the rocket as it's coming back down. It looks awesome. Then the booster will coast down through the atmosphere, losing more velocity to friction as it's guided in by aerodynamic grid fins. At the last moment, the engines will reignite one more time to make sure that the booster velocity reaches 0 at the moment that the landing legs touch down on the floating platform. This is a procedure that SpaceX has now repeated well over 100 times, and these days, they make it look pretty easy, but that was not always the case. It took SpaceX a lot of trial and error and multiple upgrade cycles to the Falcon 9 before they could truly stick the landing. Most people might not realize that the Falcon 9 was not a genuine reusable rocket until SpaceX achieved its final form in 2018, known as the Block 5. Most rockets don't really go through an active development cycle once they begin operation. The design they have on the first successful launch is more than likely going to be what they stick with throughout the life cycle of the product, and that's because rockets are very temperamental and dangerous vehicles. Anytime you change a design, you introduce an unknown variable, which could then in turn lead to a failure, and no one wants that. Unless you're SpaceX. Another bit of Elon philosophy: if things are not failing, you are not innovating enough. Let's start with the Falcon 9 version 1. The first iteration of this rocket was actually a lot smaller at just about 46 meters in total length, and a lot less powerful at just 1.1 million pounds of thrust. Even though SpaceX had already intended to make Falcon 9 a reusable booster, this version didn't receive any of the necessary grid fins or landing legs to make that possible. They wanted to make sure that it went up properly before they thought too much about getting it back down. This Falcon 9 flew 5 missions, including one to send a Cargo Dragon capsule to the ISS. Next up is Falcon 9 version 1.1. This variant grew significantly to over 68 meters in length. It was the first to utilize the Merlin 1D engine and the circular Octaweb engine layout. This increased the total thrust to 1.3 million pounds. That extra size and power made this the first Falcon 9 capable of a controlled return to Earth because it could get a payload into orbit with enough fuel left over to perform the necessary re-entry and landing burns. SpaceX began experimenting with this capability in small-scale tests where they would attempt to bring the rocket down for soft landings over the open ocean. It wasn't until the CRS-3 mission to resupply the ISS in April 2014 that the Falcon 9 received its first set of landing legs. And then for CRS-5 in January 2015, the first set of grid fins were added to achieve more precise control when free-falling through the atmosphere. This gave SpaceX the confidence to attempt their first ever drone ship landing on that same flight. It didn't work, but they got surprisingly close for something that was thought to be genuinely impossible at the time. None of the version 1.1 rockets ever successfully landed, and then in June 2015, the Falcon 9 experienced a mid-air failure and broke apart. This gave SpaceX enough pause to shut down operations until they were able to come back with another revision to the booster design. Falcon 9 version 1.2 is also sometimes referred to as Falcon 9 Full Thrust, just slightly longer now, reaching 70 meters in length and gaining a massive increase in power to 1.7 million pounds of thrust. Most of this power gain came from SpaceX cooling their liquid oxygen and rocket fuel to lower temperatures, which increases their energy density. This is where SpaceX really followed through on their promise to learn through failure, because the first launch of the Falcon 9 Full Thrust also marked the first successful landing of an orbital rocket booster in the history of spaceflight, with the booster touching down onto a SpaceX landing pad at Cape Canaveral. The Full Thrust went through a series of small tweaks and variations over the years as SpaceX prepared to finalize the rocket into its ultimate form. The reason that they had to do this was in order to get the Falcon 9 crew rated by NASA. It's fine to play around with variables when there is only money and equipment on the line, but once it's agreed that a rocket is safe to carry human beings, then you have to stop messing with it. So we arrive at the Falcon 9 Block 5. It's the exact same size as the previous version, and only slightly more powerful at 1.8 million pounds of total thrust. The most obvious visual cue to identify these variants is the black paint in the middle and on the landing legs. The real upgrades here are being made to increase the overall reusability of the rocket booster. Remember, we talked about the difference between reusable and refurbishable. The Falcon 9 Full Thrust was refurbishable in some situations, but for the most part, SpaceX only recovered those boosters. They didn't reuse them very often. The first SpaceX launch to use a refurbished Falcon 9 happened in March 2017, and it made use of a booster that had been recovered over 1 year prior. As far as changes with the Block 5, SpaceX upgraded the turbopumps inside their Merlin engines when it was discovered that the units formed very small microcracks after being launched and recovered. The grid fins on the side of the rocket were also made stronger with an upgrade from aluminum to titanium metal. At the time, these fins were the largest single pieces of forged titanium ever made, and therefore incredibly expensive, but this gave them a much greater resistance to the heat of re-entry and greater control over the rocket's angle of attack as it coasted through the air. The entire body of the Falcon 9 was given a thermal protective coating that reduced heat absorption across the entire rocket. In addition, a new reusable and replaceable liquid-cooled heat shield was added to the base of the rocket for greater protection of the engines and plumbing system. The Block 5 landing legs were upgraded to allow them to both extend and retract. The previous legs actually couldn't fold back up after the rocket was recovered. They had to be unbolted and removed. SpaceX also made an improvement to the CPOVs on the Block 5. These are ultra-high pressure tanks that are wrapped in carbon fiber. They are used to store helium gas that maintains pressure inside fuel tanks as they empty, and a COPV failure was linked to both of the previous Falcon 9 explosions, one in air and one on the launch pad. It's been 5 years now since SpaceX made all of those reusability upgrades to the Falcon 9, so what do they have to show for it? Did they make a truly reusable rocket? Earlier this summer, on July 10th, SpaceX successfully launched and landed Falcon 9 booster B1058 for the 16th time. This is the same booster that launched astronauts Doug Hurley and Bob Behnken to the International Space Station in May 2020, the first time a crew had ever flown on a SpaceX rocket. So that's 16 flights in just over 3 years. SpaceX had originally believed that the Falcon 9 Block 5 would be good for up to 10 launches and landings, but that lifespan projection increased to 15 launches in 2022, and right now SpaceX has certified B1058 for up to 20 launches, and based on extended life vibration testing by SpaceX engineers, they think that the Block 5 could withstand as many as 60 launches and landings. For comparison, the Space Shuttle Discovery completed 39 missions, more than any other shuttle in the fleet. On average, there were only between 5 and 8 space shuttle launches in any given year, with 135 total missions spread across 30 years and 5 vehicles. So that's not a whole lot of precedent to work with, but according to the numbers that we do have, yeah, the Falcon 9 is an extremely reusable rocket booster, and a good one at that. So now, all we have left to do is sit and wait for the next leap forward to begin. Can the Starship take reusable rockets to the next level? Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.